how to graph sine and cosine functions. And also in this video we focus on without phase shift first. So let's start with the formula. F of x equals a sine bx minus c and then plus d. However, like what I said, we try to work on it without phase shift, so right now we don't need to worry about minus c. So the formula will be bx plus d. Alright, and then similar to that, we have cosine on this side, f of x equals a cosine bx plus d. And again, for these, is without phase shift. And we will have another video talk about the sine cosine function with phase shifts. Alright, so now let's label it. A means amplitude, and when we find the value of amplitude, always find the absolute value of A. Same meaning on this side, so everything should be the same for both sine cosine function. When you label A, the meaning of A, B, and D, they are the same for both functions. And then for B, so for B, you don't see B in your on your graph, but you use B to find your period. And the formula for period, P for period equals 2 pi over B. Okay, and then for D, it tells you whether your graph shift up or down. Also, it's the midline. Alright, so let's start with first example. So f of x equals sine x, we already learned this one, and we will try to make a table. So then if we make a table, we have x, which is theta, and y, which is the ratio of sine x, or f of x. And then I will choose 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. Remember the reason I choose these points, because it's give me the whole number for the y values. So sine of 0 pi give me, so on this side 2 pi y have sine of 0 pi, let's give me 0, sine pi over 2 give me 1, sine of pi give me 0 again, sine of 3 pi over 2 give me -1, and sine of 2 pi give me 0 again. So let's do a quick graph right here. And then I have 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. So now I go ahead and plot it. Now I have at 0 pi I have 0. At pi over 2 I have 1. Now I also need to label this x-axis, this y-axis. And the highest point for y-axis is 1. And the lowest point is -1. And then at pi I have 0. At 3 pi over 2 I have -1. And 2 pi I have 0. So connect all of these points together. I have my graph of sine x. Okay, so that's how we do it long way. Now how we do it shortcut based on the formula. So if I rewrite this one, so my f of x equals sine x, and right underneath it I write the formula f of x equals a sine x, sine bx plus d. So then for a is the number in front of x, the number in front of sine of x, and I don't have any number here, that means it's 1. Okay, so my a equals on my amplitude equals absolute value of 1, which is 1. And it actually matched to my graph here. Okay, amplitude of this graph is 1. Alright, and then next, we're looking for b. B value is the number in front of x. And in this case, we don't have any number, that means 1. So my b equals 1, and then that helped me find my period. So period equal 2 pi over b, that means I have 2 pi over 1, and I get 2 pi. So remember, period is the distance from 2 consecutive maximum point or 2 consecutive minimum point. So that means if I keep going with my graph here, because right now on my graph I only have 1 maximum point and 1 minimum point, but in order to help you guys see it easier, I go with the next one on the graph. So 5 pi over 2, and if I do that on the table, 5 pi over 2, I plug it in, sine of 5 pi over 2 also give me 1. So I go back here, I get this one, and extend my graph here. So now I have 2 maximum points. One right here, which is pi over 2 comma 1, and the other one right here, which is 5 pi over 2 comma 1. And based on the formula with the shortcut way, I have my period is 2 pi. Now I need to confirm whether it really worked out for my graph. So on my graph, if I want to find period is the distance of 2 consecutive maximum points or 2 consecutive minimum points. So we're doing 2 consecutive maximum point now. And to find the distance, I take 5 pi over 2 minus pi over 2. It's give me 4 pi over 2, and which is 2 pi is matched. And then next, for D, we don't see any number right here. That means we plus 0. So we have D equals 0. So that means our midline is 0. And yes, we see midline right here is 0. Okay, so it matches to our midline based on the formula. So now we can try to graph f of x equal cosine x using shortcut. So we can see there's no number in front of cosine of x. That means 1. So then a equals to 1. Absolute value of 1 and is 1. So that's the amplitude. Sorry, this should be amplitude. And then for b, there's no number in front of b. That means 1. So then we have b equals 1. So then we use p equal 2 pi over 1, and it equals 2 pi. Then for d, there's no number, it's plus 0. So d equals 0. And that means we have midline at 0. So how we use this information to quick check our graph. So then we have this. And then we know it's the 2 pi period. So we have start from 0 pi and then end at 2 pi period. So then we figured out what is halfway between 0 pi and 2 pi will be pi. And then what is halfway between 0 pi and pi will be pi over 2. And then halfway between pi and 2 pi will be 3 pi over 2. And then next we can do the amplitude is 1. Actually, we talk about midline first. So midline is 0. So this is the midline right here. And from the midline, we know the amplitude is 1. So midline is 0. Therefore, amplitude will be up 1 and down 1. So this is the y-axis, this x-axis. Alright, and then next we can really quick we do the table with just the first few points to make sure we grab it right. So theta and then y, so then 0 pi, I get 1, and then pi over 2, I get 0, and so on. So then I plot these points. 0 pi is 1, pi over 2 is 0. And if you actually pay attention to the graph of sine and cosine, they both follow the same pattern. If you have a high point, which is maximum point, and then the next one that we choose as the whole number will be on the midline, and then the next one will be the minimum point. So then for the next corner at pi, we have minimum point, which is -1, and then we go back to the midline, and then we go back to maximum point. Okay, so that way we don't need to finish the whole table if we know the pattern. And we connect all of them. So that's our graph. Okay, You can double check it by finding, and then for this graph, it's just one period, but we already have 2 maximum points, so it's possible for us to check the period. So then the coordinate right here will be 0 pi comma 1. Coordinate right here is 2 pi comma 1. So to find the period, we take 2 pi minus 0 pi, and yes, it's 2 pi, and it's equivalent to period we have right here. Okay, so no matter which way you do, you can do the long way with the table, or you can do the shortcut based on the formula and the meaning of each variable in your formula. You should end up with the same graph. And start working on one of these symbols that have cosine, sine with different midline and different amplitude compared to the parent's graph of sine, cosine. Okay, so for example, I can create a function f of x equals 3 sine 2x plus 1. Okay. So then if I use shortcut way, I rewrite it at f of x equals a sine bx plus d. So then I see my amplitude is the absolute value of 3, and it's 3. My b value is 2, so my period equals 2 pi divided by 2, and it's give me pi. So pi is my period in this problem. And then d equals 1, so that means my midline start at y equals 1. Okay. So now go ahead and sketch my graph. Alright, now we try to graph this function. So we know always start with the midline. Midline is y equals to 1. So we have y equals 1. So this y-axis, this x-axis, y equals to 1 is right here. And then for the amplitude is 3. So therefore that means from the midline, you go up 3. So 2, 3, 4. And from the midline, you go down 3. So 0, -1, and -2. Okay. So that will be your maximum point and your minimum point. Usually I also draw a line since I know that my sine wave cannot bounce farther than 4 or -2. Okay, and then for period, my period is pi. So then I start with pi at the end. That's one period on my graph. And at this time, because we don't have phase shift yet, so it will be 0 pi. So right here is 0 pi. Okay, then we figured out half of 0 pi and pi will be pi over 2. And half of 0 pi and pi over 2, we take pi over 2 divided by 2, you get pi over 4. And basically you will count by pi over 4. If you don't want to do extra calculation on pi and pi over 2, add up and divided by 2, then you can count by pi over 4 for each increment. So 0 pi, pi over 4, this known as 2 pi over 4, and because you reduce it, that's why it's go back to pi over 3. And then next one is 3 pi over 4, and pi will be 4 pi over 4, and we'll reduce to get pi. Okay, so hopefully it helped you understand why I jumped from pi over 4, pi over 2, 3 pi over 4, and pi. Alright, and then we can work on the table. So with the table, you can create table x, which is the data, and y. And then first one, 0 pi, plug it in, we have 3 sine 2 times 0 pi, and then plus 1, and so on. then that will give you 1. Okay, so at 0 pi you get 1. And then if you go to the next one, it will be pi over 4. And then now we have 3 sine 2 times pi over 4, and then plus 1. And if you evaluate it, you will get, this one give you 4, right? So at pi over 4, I have 4. And then so on. So you plug in each of them, then you get, at pi over 2, you get 1. At pi over 3 pi over 4, you get -2. And at pi, you get 1. So connect all of them together. This will be your graph. Okay, so hopefully this helps you understand more about how to graph a sine cosine function with the shortcut way. If you don't like this way, that's okay, just start with table.